హాయ్ స్టూడెంట్స్, మన గన్ షాట్ సిరీస్లో నెక్స్ట్ ప్రాబ్లం ఈ ఐఐటి జేఈ అండ్ నీట్కి సంబంధించినటువంటి ఇంపార్టెంట్ మోడల్స్ చూస్తూ ఉన్నాము. ఫ్రీక్వెంట్లీ ఆస్కింగ్ క్వశ్చన్స్ ఏంటనేది దాంట్లో భాగంగా నెక్స్ట్ క్వశ్చన్. ఏ గ్యాస్ ఆక్యుపైస్, see the question, a gas occupies 0.418 liters at 740 mm of Hg and 27 degrees centigrade. Calculate its volume at STP and molecular weight if gas weighs 3 grams. So direct problem ఇది, frequently asking questions లో ఇది ఒకటి. So here what is given? Volume of the gas is given. How much? That is 0.418 liters. And what is given here? That is V1. And pressure P1 is equal to 740 mm. That is nothing but 740 by 760 atmospheres. Okay. Because 760 mm of Hg is equal to 1 atmosphere. You know very well. Therefore, 740 mm of Hg is equal to how many atmospheres? That is 740 by 760 atmospheres. Like that. And temperature is given. T1 is equal to 27 degrees centigrade. Okay. And calculate its volume at STP. See here, these are experimental conditions. Experimental conditions. STP conditions. What are STP conditions? Temperature T2 is equal to 273 kelvins. 273 kelvins temperature. Pressure P2 is equal to 1 atmosphere. And we have to find the volume at STP. V2 is equal to how much? So these are STP conditions. So according to ideal gas equation, that is, according to ideal gas equation, PV is equal to nRT, isn't it? PV is equal to nRT. And then equation of state, that is P1 V1 by T1 is equal to P2 V2 by T2. Based on that formula you can solve, isn't it? Because P1 V1 T1 experimental conditions are given, you have to find the volume at STP conditions. Standard temperature and pressure we know very well. So that is temperature 273 kelvins and pressure 1 atmospheric pressure. What we have to find here? Volume V2. V2 we have to find. Okay, so therefore V2 is equal to P1 V1 into T2 divided by T1 into P2. Substitute those values here. How much? That is, see here, P1, how much P1? Pressure 740 divided by 760 into volume V1, how much? That is 0.418 into T2, how much T2? That is 273 kelvins. 273 divided by T1, how much T1? 27 degrees centigrade plus 273, that is nothing but 300 kelvins. 300 into P2, how much? 1 atmosphere. So simplify this one. Then you can get answer. Do it. Do your own. How much? Okay. that is 0.394. 0.394. So its volume is 0.394. Here 0.418 liters becomes 0.394 liters at STP if temperature and pressure changed from 740 mm to 1 atmosphere and temperature 300 degrees centigrade to 273 to 300 kelvins to 273 kelvins. Okay, so this is important problem. Next one. Okay. Now calculate the density of carbon dioxide at 100 degrees centigrade and 800 mm Hg pressure. See, in this problem what you have to find. What data is given here? Calculate the density. We have to find the density of carbon dioxide gas at 100 degrees centigrade and 800 mm of Hg pressure. Okay. So we have to find density. So according to ideal gas equation, you know very well, PV is equal to nRT or PV is equal to W by M RT or P is equal to WRT by VM or P is equal to, instead of weight by volume, mass by volume, this is nothing but density, dRT by M. We have to find the density. Therefore, density is equal to PM by RT. So, PM, pressure, how much pressure is given here? 800 mm. 800 mm. Pressure is equal to 800 mm. That is in atmosphere, that divided by 760 atmospheres pressure. Okay. Temperature is given. T is equal to 100 degrees centigrade plus 273. That is 373 kelvins. Okay. So, molecular mass M means molecular mass. How much molecular mass of carbon dioxide? That is 44. You know very well. So substitute those values. Pressure 800 divided by 760 into molecular mass of carbon dioxide 44 divided by R value in liter atmosphere 0.0821 into temperature. Temperature is 373 kelvins. Now here density becomes, here molecular mass is taken in grams. Here R value is taken in liter atmosphere. That is why gram per liter. Here density units gram per liter, not milliliter. Okay. Not gram per cc, gram per liter. So how much? Do it. Do your own. Okay, completed. So that is about what you call next problem, finding of density if data is given like this. Next question. See, look at the board. Next, third problem. A gas at 0 degree centigrade and 1 atmospheric pressure occupies 2.5 liters. 0 degree centigrade, 1 atmospheric pressure occupies 2.5 liters. What change in temperature? We have to find the temperature. What change in temperature would be necessary if the pressure is to be adjusted to 1.5 atmospheres? Pressure 1.5 atmosphere changed to 1.5 atmospheres. And gas has been transferred to 2 liters container. See, data is given like this. Initial temperature T1 is equal to 0 degree centigrade plus 273. That is equal to 273 kelvins. At pressure P1 is equal to 1 atmosphere. And volume is given. V1 is equal to 2.5 liters. Okay, like that. And what temperature would be necessary? Means we have to find a T2. We have to find a T2. Okay. And then if pressure is to be adjusted to P2 is equal to 1.5 atmospheres. Okay. And has been transferred to 2 liters vessel. V2 is equal to 2 liters. We have to find a T2. So what is the relation between P1 V1 T1 and P2 V2 T2? P1 V1 by T1 is equal to P2 V2 by T2. Equation of state. Okay. So in which what we have to find? T2. Therefore T2 is equal to T1 into P2 into V2 by P1 into V1. Okay. So T1 how much? That is 273 kelvins into P2. How much P2? 1.5 into V2 volume 2 liters final volume, and P1 initial pressure 1 atmosphere, V1 initial volume 2.5. How much? Do it. See, 1.5, 2.5 means 15 by 25. 3 5s, 5 5s. Okay. And then here 5 5s are 25. 2, 3, approximately 5 times. 55 into 3 into 2. 3 into 2, 6. 55 into 6, approx value. 5 30. 33, 33. Okay. That is approximately 330. Like that. Okay. So that is one of the important models. Now next one. So those are the models, today's class models. Next, other models I will explain in next class. Okay, right, thank you.